Okay, continuing on with lesson 1. Now we're on day 5. Revisiting some of the things that we've already talked about and then something brand new today. A little bit of an extension of what we've been talking about for the past 3 or 4 days. Okay, so we look at our warm-up. Here we have generated all the possible 3-letter permutations of the 4 letters D, E, F, G. So if we were to write this as a permutation, we had 4 permute 3. Or like in the homework last night, we talked about taking 3 at a time. That was another way that we could talk about just permuting 3 out of the 4 that were given. So they did that for us. And if we do this permutation, we have our, go back to our calculator here. If we do 4p3, so 4 math over to prob, number 2, we have 4p3, we get 24. Oops. Oh, okay, now I'm where I want to be. We have 24. That's 4 permute 3. Another way that we could do this, and we talked about this yesterday, is to map it out, where we give ourselves the little spaces that we can use, and we put 4 choices, 3 choices, 2 choices, and we do the math, and we get the same 24. And this should look very much like the 4 books problem that we did the other day. Here's our 4 permute 3, which is ordering 3 out of our 4 letters. The one method that's not going to give us the correct number of permutations is 4 factorial. Now you're going to tell me that we will get the same thing because 4 factorial is 4 times 3 times 2 times 1. And in this case, because we're just permuting 1 less than what we have, that is the case. So I guess just like we had in every case where the number we permuted was the number that we had, always ended up being that factorial. It will also numerically be correct when we're just permuting 1 less, but that's not the general rule. So the general rule is we get the 4 factorial when we do 4 permute 3. So here we want to analyze the sample space that we have above for all those permutations. And what it says is to start at the top left of the list with DEF. Circle DEF. Then we need to cross out all the outcomes with the same elements as DEF, but in a different order. So an example would be EDF right next to it. It has the elements of a D and an E and an F, but they're just in a different order. It is a permutation, but that's really not what I'm looking for here. So you need to go ahead and do that and follow on to the next couple of sets here. And we'll see what we're left with. Okay, we just look at what we should have crossed out so far from this first bullet point. This is what we should have. Now it says go on to DEG. Circle DEG, and then cross out all outcomes with the same elements as DEG, but in a different order. For example, EDG, and that's right next to it. So go ahead and do that, and then we'll come back and we'll check to see that we did things correct. All right, now we're going on to DFG. We're going to circle that one and then cross out all the outcomes with the same elements, but that are in a different order. For example, F, D, G. Oh, I'm sorry, DFG is what we were going to. So, DFG. Circle it, and we're looking for FDG. That one right there. All right, and then the last one, we find EFG. This guy right here, circle him, and then we're going to cross out anybody that has the same set of letters, which would be, I see an E, an F, and a G, 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 an E, an F, and a G. It looks like we got rid of a lot of things. And the arrangements that are left, the ones that we circled but did not cross out, DEF, DEG, DFG, and EFG, we're going to call combinations of the three letters from the set of letters DEFG. A combination is an unordered collection of items. Like the permutations, different notations can be used to denote combinations of R elements taken from a collection of N elements. Again, the number we have, and then this is the number that we are going to go ahead and use. Sometimes N is equal to R, so we can have N and R be the same. In general, N is greater than R. We don't use everything that we're given. What cannot be true is N is never less than R. So for permutations, some people did that on their homework, and that is never true. We cannot pick or use more than we have. Okay, so if we kind of look at the situation that we just did, we had 4 permute 3. That's how we got our 24. That's how we got the list of all of those 24 outcomes in our sample space for our permutations. However, if we change from order being important to order not being important, we're talking about a permutation, and we go from 24 down to 4. Now, like we talked about yesterday, we always start with that n factorial in all of these scenarios that have a formula. That is kind of our max out potential sample space number. But depending on the situation, we may need to make tweaks to that. And a tweak would be when we're permuting less than what we have. R is less than N. Again, we need to make a tweak when we're saying that order is not important. And so we need to kind of think about how we can go from 24 down to 4. Think of a divisor that is a factorial that equals 6. So you can figure out what 1 factorial equals, 2 factorial, 3 factorial, and you should come up with your answer. All right, we'll do this one more scenario together, and then I want you to complete the other scenarios on your own. So again, we're using that same set of 4 letters, D, E, G, F, but here we're taking 2 at a time. So this would be like the homework yesterday, permuting 2 at a time, or 4 permute 2. We get our calculator, we use the formula, we find out that is 12, and we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything is making sense. Now we need to figure out how many combinations we have. So like in the previous example, we start with ED and we're going to cross off anybody that has the same 2 letters as E and D. Then we go to DF and we're going to cross off anybody that has those same 2 letters. Then we move to DG and we cross off GD. And we move to EF, and we cross off FE. And we move to EG, we cross out GE. Finally, we're at FG, and we cross out GF. So for our combinations, that's the ones left circled. 1, 2, 3, 4, 5, 6. So we have 6 when we do 4 combination 2 versus permutation 2. Again, this is when order does not matter. Okay, again, we want to think of a value that we could divide our permutation, which is 12, by to end up with 6. But you can't just write down 2. You have to think of what number would give, what factorial of a number would give you 2. So again, if you figured this stuff out here, you should have your answer of 2 factorial. All right, I need you to go ahead and do these other scenarios, similar to the 2 that we did. Complete that information, and then you want to take that information and put it in this table. So I'm going to go ahead and fill in for scenarios 1 and 2, because those are the 2 that we did together. So the n that we started with in scenario 1 was 4. We did 4p3. And our r then was 3. Our permutations were 24. And we divided those permutations by 3 factorial to get 4 combinations. Again, this is order not important. This is when order is important. You look at scenario 2, again, we started with those same 4 letters, but there we only took 2 out of the 4. We took 2 at a time. When we calculated or counted up our permutations of 2 at a time from 4 items, we ended up with 12. We divided that 12 by 2 factorial to end up with the number of combinations, which would be 6. All right, so you need to finish filling out that table and come to some conclusions. And you can use the formula to calculate our combinations. And we've got some directions on the calculator to find the combinations. It's in the same spot as the permutations. And then we have a worked out example here, a guided example that you can use to go ahead and complete the rest of the packet. And when you're done with that, what you want to do is you want to be checking with someone in your group or checking with the teacher to make sure you're getting things correct. And then your exit slip here. You can turn that in. Maybe we can have one person from the group turn that in for the entire group and then get the practice